Okay, so for the final part of homework 7-4 here, we just have question 10 to wrap up, and I'm hoping this will be a pretty quick video for you guys. Question 10 I don't think is too terribly difficult. But anyway, Potter's wheel with the rotational inertia they give us here is spinning freely at 40 RPM, so revolutions per minute. Potter drops a lump of clay on the wheel where it sticks a distance 1.2 meters from the rotational axis. If the subsequent angular speed of the wheel and clay is 32 RPM, what is the mass of the clay? So the key concept here, right, originally the wheel is rotating with whatever its revolutionary velocity is, and it's rotating, right? As we then drop the blob of clay a certain distance from the center of rotation, it causes the wheel to slow down, right? And why does it cause the wheel to slow down? Well, by dropping it onto the wheel perpendicular to the way that the wheel is spinning, I'm not generating any torque. And so the net torque would then be 0. And if the net torque is 0, what does that tell us? Well, again, the big conclusion that tells me is the angular momentum of this system should be conserved. So the angular momentum before and afterwards should be equal, right? So the angular momentum beforehand, which comes from the moment of inertia times the angular velocity, of the wheel, would be equal to the moment of inertia of both the wheel and the clay, and then the angular velocity of the two together, right? So if I start to look through here, well, they give me the rotational inertia, the moment of inertia for the wheel itself. And before the collision, if you will, that is the only thing moving, right? That's the only thing spinning. So that's the only number I use on this side of the equation. So 46 kilograms times meter squared, that represents my initial moment of inertia, right? And the angular velocity, I could certainly convert that to radians per second. However, since both of these are given in RPM, and that happens on each side of the equation, I'm going to go ahead and just leave them in RPM, because I'm still leaving this equation as a balanced equation in doing that, since I'm doing it on both sides, right? So I've got that on my left-hand side. I've got my initial angular momentum. And then on the right-hand side, the only thing you have to be careful about is after the collision, you have both the moment of inertia of the wheel, which we know is 46, plus the moment of inertia for the blob of clay, right? And then finally they tell me the final angular velocity is 32, right? So solving it from here, just a matter of doing a little bit of algebra, right? So if I solve it from here, the moment of inertia of the blob of clay ends up being about 11.5 kilograms times meters squared, right? So this whole moment of inertia is 57.5, and then finding the difference there is about 11.5 kilograms times meters squared. And then they ask me to find the mass of the clay, so make sure we do take this all the way. So if this is the new moment of inertia caused by the clay, I just have to think about what would be the relationship that helps me find the mass. Well, the moment of inertia for an isolated object like this that's rotating around a pivot point, right? I'm just using the full mr squared. I'm not using any coefficients out front because the entire mass of the clay is located that same radius away, right? So the moment of inertia, which I just said was 11.5, I don't know the mass of the clay, that's what I'm looking for, but I do know that it was plopped down 1.2 meters from the center of rotation. So then just solving this equation is 7.99 kilograms, and that is my mass. So 7.99, about 8 kilograms, that should be the mass of our clay blob. And again, that finishes out part 3 of homework 7-4. Obviously, if you guys do have any questions or catch any mistakes in these videos, just let me know, and I'm happy to go back through those if I need to.